Hey everyone, today we're going to talk about something which everyone knows or has at least heard of at some point of their life. This is one of the most valuable achievement of human race. Yet, this is the celebration of 100 years old Einstein's general theory of relativity for still standing straight. I am SR Riang and welcome to my another video. On April 10, 2019, for the very first time, the humanity had seen an unseeable. Whatever we have seen or we do know about this object comes from the equations and theories put together by physicists like Albert Einstein, Stephen Hawking, and others. Yes, my dear friends, I am talking about black holes, one of the most mysterious and one of the most massive objects in our universe. So, what actually is a black hole? According to Wikipedia, a black hole is a region of space-time exhibiting such strong gravitational effects that nothing, not even particles and electromagnetic radiations such as light, can escape from it. So let's take an account of how a black hole is formed. When a massive star, at least 3 times the size of our sun, burns out of its fuel, it collapses under its own gravity. At some point, it squeezes up to the size of a football ground. After this, it results into a huge explosion, releasing a huge amount of energy known as supernova. After the explosion, what remains is the core of the sun. And the leftover of the explosion falls on a small infinite point, and this is known as the singularity of the black hole. And this is the point from where everything begins. The black hole keeps on filling the material around it and keeps increasing in its size. And this is how the first ever image of a black hole looks like. Amazing, right? So now you all might have been thinking that if nothing can escape a black hole, not even light, then how scientists have managed to capture its image? The fact is, what we are seeing is not the black hole, but the shadow of a black hole. Moreover, it is captured with the help of a huge radio telescope known as EHT, Event Horizon Telescope, which is of the size of the Earth. It is made by combining 8 radio telescopes located at different regions all over the world. So what we are actually seeing, or what we have actually captured, is the radio waves, not the light coming from the black hole. The radio waves are later processed into an image, and that is what we have seen. Now let's try to understand the image of the black hole we have gotten. Okay, so now we'll be trying to understand the image of the black hole which we have seen. The smallest sphere in the first image is known as the event horizon. This is a point around a black hole. If something goes beyond that point, it has no return, and we don't know what happens to the object. The radius of the black hole is known as Schwarzschild radius, and here we have denoted it as Rs. Now we will be looking at the biggest circle around a black hole known as accretion disk. So what is an accretion disk? This is a disk of stable orbit formed around a black hole, which is composed of dust and matter, where the things revolve around with the speed of light, nearly with the speed of light. If something goes beyond this point, it has no return. But my dear friends, as you know that light has no mass, so it can revolve around a black hole from much closer distance, that is with a distance of 1.5 Rs, while accretion disk is at a distance of 3 Rs. And this orbit where the light revolves around the black hole is known as photosphere, and this is the point where light happens to bend due to the huge gravity of a black hole. Though it is not possible, but if you ever happen to be in photosphere, you will be actually seeing your back in your front, because since the light is bending, it just revolves and comes in front of you, and you will literally seeing your back. Now we will be looking at the much bigger picture. Here it is the event horizon, and this is the photosphere, and this is the accretion disk. We know that the photosphere is an unstable orbit. It means that here the photons have to either go inside the event horizon or otherwise go out of the photosphere. So what happens that if a photon is coming from far away, it just gets absorbed inside the event horizon, and if it's coming at some higher level with some angle, still it just gets bent and it goes inside the event horizon. Just see how the light rays are getting bent and is getting absorbed inside the event horizon due to the huge gravity of the black hole. If the ray of light is coming at the level of photosphere, still it is getting inside, it is getting absorbed inside the event horizon. And if the if the ray of light is coming above the photosphere, still it is getting inside the event horizon. But if the photon or the ray of light is coming at a distance of 2.6 Rs from the event horizon, then what happens is that it just comes, it gets bent, it just grazes the photosphere and it goes out. And this is the ray of light or photon captured by our telescope. And this is the image of black hole which we will be getting, and this is how the image of black hole will look like if the position of the earth and the black hole is something like this. Now again, this is the event horizon and this is the photosphere, but here the position of the accretion disk is something like this. So here in this case, the image of the black hole which we will be getting will be a bit different. So what happens in this case is that when light comes from the back side of the black hole to this front part, what happens that since we know that the light is getting bent near the black hole, the light from the back side of the accretion disk will come and bend here, and we will be seeing the back side of the accretion disk here. Again, the light from the accretion disk will also come from below the black hole and pictures the accretion disk here. So the image of the black hole here in this case we will be seeing will be something like the black hole of Interstellar. But we will be seeing this kind of image when we are too close to a black hole, and the black hole is a non-rotating black hole. But the image of the black hole captured by Event Horizon Telescope at the center of M87, that is Messier 87 galaxy, the black hole is a rotating black hole. But the image captured by AHT confirms that the position of the black hole with respect to Earth is something like this. And in the image of the black hole, we are seeing the accretion disk. And we can see that one part of the accretion disk is a bit brighter than the other part. This is due to the fact that the matter around the accretion disk is revolving with the speed of light. So the light coming towards us looks more brighter than the light going away from us. So this is what all I know about the first image of black hole. If you have any doubt, please don't forget to leave in the comment box, and please don't forget to like, share and subscribe. Thank you everyone.